Hello and welcome to Console Cowboys. In this video, we're going to take a look at some different aspects of smart contracts, in particular events that are emitted from the contract and how to monitor those, as well as some different aspects of Python programming. In particular, we're going to look at the Async IO library, which often you see in JavaScript with the await keyword and asynchronous programming. We're going to take a look at how that's used in Web3.py. So first off, what is an event? If you're not familiar with smart contract events, let's take a look at what they are. So in our HelloWorld Bank contract, you'll see here we have an event and we name that deposit log. And this event is going to send a sender, a value, and a message. And when we hop into the deposit contract, you'll see where that's used. So within the deposit function, we have our normal stuff of updating the balance of the user and taking in the value, etc. And then after that's done, we emit a deposit log event. And this deposit log event is going to take the message.sender, which is the person who deposited funds. It's going to take the value that they deposited and then any message that's in here, and it's going to emit that from the smart contract. Now, if you had a web page that was using this bank as a back end, you could subscribe to these events, and then when they happen, you could have the web page parse them and then put the data on the screen. However, as a hacker who wants to monitor things, we can also subscribe to these events on the smart contract pretty easily. And what this affords us is maybe there's some debug statements that were left in by a developer and it's immutable code, they can't get rid of it, and maybe it keys us into something. Or maybe we want to know when a specific user is depositing a value and we can subscribe and then parse for that and filter it out. Whatever your reason is, this is another aspect of smart contracts that you should understand what type of data is being emitted from that smart contract. Let's talk about the setup for this video and then we'll get in here and start coding it. It's not going to be a crazy amount of code. It's actually pretty short, but it's a totally different way to think about how we were hacking around on smart contracts and learning with interactions. So it'll be pretty interesting. So first off, we have our standard template that we've been using, which has our target address, our target ABI, creates that target variable that we can use to communicate to the smart contract. So paste that in there. And then we have our Ganache connection to the local blockchain on 127.0.0.1.75.45. And of course, I have launched Ganache, which is what we're going to connect to. Next up, we have to grab our address and we have to grab our target ABI. So let's do that now right out of Remix. So if we go back to Remix and we go to the Compile tab, we can hit Compile. And then next up, we're going to have to change the environment down to Ganache again. So let's do that. It's going to be dev Ganache provider. Make sure if you're using this GUI based one that you switch that out to 7045 because this 8545 is the default for the text-based one, but we're going to be using the UI in this one, or at least I am. If you are using the other one, then leave it alone. Next up, we are going to deploy this contract. And then once we deploy it, we're going to grab the address. We'll paste it into our address field. And then we will grab our ABI. So our ABI is going to be back here again. We go to the bottom, and instead of going to ABI, we're actually going to go to compilation details. And then we go down to web3.deploy. And if you remember correctly, this is just so we don't have like a huge like 30, 40 line thing within our code. It just goes across one thing. All we have to modify is remove everything, including that parentheses at the back end of that. And then in the front end of that, the same thing from the parentheses to the beginning. And then you now have a connection to the blockchain. You now have a connection to your smart contract using this target variable. The first thing that we're going to do in here is we're going to say, hey, is this file being imported or is this the main file that's being run? If it is, let's call the main function. That's just the typical way to do that in Python. This is like standard syntax. You can look it up. So that's going to call the main function. So we got to create that main function. Now within our main function, what we want to do is we want to create an event filter. And this event filter is going to monitor our smart contract events. And for each of the latest blocks, it's going to say, hey, Did the deposit log event kick off? Let's filter for that. I'm just gonna paste this in and actually explain what it is. That way I don't screw it up too much. So we're just gonna say, hey, let's create an event filter. And we're gonna say target, which is our target contract up here we created. This is just our connection to the contract. And we're gonna say events. So usually we've been using functions, but that was when we were interacting with the smart contract functions. What we're gonna do now is we're gonna monitor the events. And then the event that we wanna monitor is our deposit log event, which is right within our smart contract. We saw that earlier. And then we're gonna say, hey, let's create a filter. And what do we wanna filter on? We wanna filter on our latest block, right? And you're gonna ask, like, how did I know how to do this? Where did I get this from? And that's actually really easy to answer. Again, we're gonna tell you, go to the documentation. So in the documentation under filtering, you're gonna see an event filter, my contract, events, my event, create filter from block latest. And then they have some other argument filters as well as, other things in here that you can play around with. And I suggest that you actually do go in there and play around with a little bit. So once we got that filter and we can monitor for that, what we're gonna do is we're going to call an asynchronous function with our event filter that is going to loop through and poll for those events. So here's what we can say. First, we need to import Async IO. So import Async IO. Once Async IO is imported, we can say, I'm gonna paste this in here again so I don't mistype it. We're gonna say async IO.run. And what do we wanna run? Well, we wanna run a function that we create that's gonna be an asynchronous function. And we wanna pass our event filter into there because that is what we're gonna use for looking for all those new events. And then we're gonna post in a value. And this value is going to be a sleep value for an asynchronous sleep in between each of the iterations of the loop. So the next thing that we have to do is we have to actually create this asynchronous function that we're gonna call, right? So let's do that. We're gonna say async define, and we're just gonna call this function. And then what we're gonna do is we're gonna call this our poll interval. So now we're using async IO.run, we're gonna call our event loop to an async function, which handles everything that we need. And another thing to understand here is I'm using async IO.run, but if you actually look this up online, especially for monitoring smart contracts, you're gonna see completely different syntax because people are using the older version, which is much more complicated. This is for, I believe, Python version 3.8 and up. And it's much more simple just to run async IO.run unless you're doing something more complex and just say, hey, let's run this event loop, asynchronous loop. But if we go back to the documentation, I can probably find it. We search for async.io. And what you're gonna find is an example for doing similar to what we're doing. But what's gonna happen is they're gonna create a loop with async get event loop, and then they're going to say loop.run until complete, async IO gather, and then they're gonna send their filter and everything through here. Now this is much more complicated than what we're doing here, and this could be useful if you're looking for something specific. But for us, all we're doing is calling this asynchronous function, so we can just use an async IO.run, which drastically simplifies our code, and that's always nice. Simpler, easier, and less amount of code is always better, especially the simpler part, because you have to read your code later on. So here's what we're gonna do. We're gonna say while true, because we want this to keep running forever. And inside here, we're gonna say for event in our event filter. What do we wanna do? Well, we wanna say dot get underscore new underscore entries. And that's it. Really, that's like the main part of our code. We're just gonna say, hey, let's get each new entry, and we're gonna use our event filter for that. And for each one of those, we're gonna grab that event. And now what are we gonna do with our event? Well, we're going to call our event handler, and our event handler is nothing more than a function we create to parse the values that are coming back. Well, now we could do that right within this loop, but since we're using functions, it's much better to separate our polling functionality from our parsing data functionality because it just makes it easier to modify it later on, and it separates our code a little bit. So we're obviously going to have to create that, but before we do that, in between each iteration of this loop, let's wait for the poll interval of the 2 seconds so that it's not just firing off rapid fire. And we normally could use sleep for that in Python, but since we're doing asynchronous programming, we're going to use await async.io.sleep. That way it'll sleep and other things can happen. So await async io.sleep. And we're going to sleep for our poll interval. Perfect. That's all we need to do. And then what we need to do is parse our data out. This is all easy peasy. Basically, all of our functionality, we already did it. The only thing we have left here is that we're going to parse out some data and print it to the screen. But as far as the monitoring and subscribing, we already just did it. But before we actually hop in here and do that, let me show you something else that's going to help you out. So if this is really confusing to you, and it might be because you might have never seen Async IO in your life if you don't code JavaScript, or if you're new to Python and haven't been doing it for a while, because Async IO libraries are actually pretty new. They're in version 3. I forget where they came out, but they're relatively new. So one place you can get a lot of information is if you go to realpython.com, there's actually a really lengthy tutorial on async.io. So just Google realpython async IO, and you're going to get a walkthrough with some comprehensive examples, some small examples, and it's going to give you a lot of good information on async IO programming and generators and up your Python game if this is new to you. So definitely check that out along with the document chasing on the filtering and all of that stuff. It's going to help you out a ton. But back in here now, let's do some modification of data and whatnot. So in here, what we want to do is format the data and then print out the data. Now we're going to need a JSON in here because we're going to play around with some JSON data that's coming back. But first off, what we're going to do is this. We're going to say, take our event and put it into a new event variable because we're going to write it over. And what we want to say is Web3, but it's not our Web3 connection to the blockchain. It's our Web3 that has the other functions like HTTP provider that we imported here. It has a function that's useful to us called .toJSON. And this is going to put it in the format that we need when we switch it over to JSON here in a second. So now we're going to write this over again, and we're going to say event equals JSON.loads, which is why we imported it up here. We're going to use it. And we're going to say event. And what that's going to give us is a JSON object that we can parse. So that'll be perfect here. So we're going to say event, use our Web3 function to JSON and make a new event object. I forgot an equal sign here. And then take that again and create another event variable. I'm going to write this over by loading it into actual JSON that we can parse out, because this is just going to give us something that's a mess. Now, what do we want to do? Well, let's first print out this event and see what the format is, so that way we can parse it out. So we'll say print event. Now, this should be all good to go unless I screwed something up in here, but hopefully we'll be good to go. And just to recap here, we're going to say, hey, is this running in the main file? If it is, let's run this main thing. Let's create an event filter that looks at the latest block. We're going to go and create that filter and check the deposit log events. And we're going to toss that into an asynchronous call to an event loop log that passes a polling interval and our event loop. Inside of here, we're just going to run forever. And we're going to say, hey, for each new entry that we find with our event filter, we're just going to say, hey, let's take that event and we're going to send it over here and we're going to parse it out. But let's sleep for 2 seconds in between each one of these while we run all of this stuff. Okay? So let's do this now. We're going to go back into Remix because in order to actually see this happen, we need to run an event. So we're going to light up this program real quick. And you're going to see nothing happen at all unless we screwed up our code. It's just going to be polling for events, but we don't have any events going on that contract just yet. We're going to create one of those. So back in Remix, we're going to go up here and we're going to say, okay, how many ether do we want to send? We're going to put this in the value column here. We want to send 1 ether across the wire. And we're going to do that with our deposit function because our deposit function had the event hooked to it. Now, if we hop back in here, we have our event. It came up, but we're still in a loop. We didn't go back to terminal. It's just going to keep looking for those events over and over and over again. We can kill it off because we're going to make some changes. But let's see what's in here. So we have args, and then we have all of our variables in here. So we have sender, we have value, and we have message. So that's how we're going to parse things out. And we can see our value was that 1 ether. We can see our message was that deposited ETH message from our smart contract. And we can see that this is who the message.sender was within Remix. And you can see that right here. You just scroll up. BDD, look at the code. BDD, perfect. That is who sent that event or who contacted that smart contract, ran the deposit, which emitted that event to be more accurate. So now let's change our code a little bit. So we know that we have args, and then we have our different variables inside of that. How do we parse that with JSON? Well, we're going to use our event, and then we're just going to say args, which gets us into that first section. And then we're going to go inside of there and say, let's grab our sender. And this should print out only our sender if we did it correctly. So let's check that out. And I always suggest you don't do a whole bunch of stuff at once. You just do one thing at a time until you have properly working things, and then you add to it. So now let's do this again. Let's say, I swear to God, my keyboard is broken, but whatever. We're going to send 2 ether, but each time I press the enter key, it's not really working. So I think I need a new keyboard. But we'll say deposit again, and we'll look back here and we'll wait. It's polling. Oh, args is not defined. And why is that? ARGS, args. Oh, that is because these need to be in parentheses. Sorry about that. These actually both need to be in parentheses. See, and that is why we do one at a time, because if we did all of them and we didn't, had a whole bunch of errors here, we wouldn't know which one is which. So let's run this again, and we'll shoot off another smart contract event. So just kind of proving my own points here. Do one again, we'll hit deposit, and we're waiting for that polling interval, and there we go. We only have the address, so cool. Let's print something else. So let's print out all of those items from that event, because if we were monitoring this event, we want all the data depending what the data is that we're monitoring. So I'm just gonna paste this whole thing in here, and it's the exact same thing we just did right here. We say event args sender, event args value, an event args message. And then, like I said, we can now pull this in to a decentralized application to print out messages to the user based on events being pushed out. Or if this is something we want to monitor from a hacker's standpoint, which, hint, hint, you may see in some future things, then this is how to do it, right? And this is how to print those things out and filter for them. So I'm going to save that. We're going to kill this off because that was still running, because that's going to run forever. And we'll hit Python again. And let's set this up to do 2 different Ethereum. Hit deposit. And then I'm going to do another one here so we can see that it just keeps monitoring. We're going to do 3 here. Deposit. And then if we hop back in here, here's what's happening. Again, we have, here's our address. This is how much was deposited. And it says deposited ETH, which is our message that's working. I must have accidentally went back to 0 here because we did 0 deposited. So let's hop back in here again because my keyboard is doing weird things. So let's do 2 again. And we'll hit deposit. And there you go. There's another 2 ether was deposited in here. So this is how to monitor events within smart contracts. This is also how to do some very simple asynchronous programming and how to, monitor those events. I hope all of this was very useful to you in a lot of contexts, from looking at different ways to use Python if some of this stuff is new to you, as well as, other aspects of smart contracts such as events, which you may or may not have even heard of if you're not a Solidity developer. These things exist out there, and these are things that you can subscribe to, but you need to be able to do some of this asynchronous programming to do that. And we'll also see that with some of the network programming with pending transactions, where we'll come back to this asynchronous programming. So you'll get used to it, the very simple format of how to do it. So hopefully you learned something in this video. If you did, please give me a like and a subscribe and let me know what you liked about the video in the comments below. You can also follow me on Twitter in the description below, and I will catch you in the next video.